Hello, welcome back. In this lesson, we will learn more about blocks and transactions. The ledger is where transactions are recorded. Its structure is a chain of blocks, hence the name blockchain. In addition to transactions, which are stored sequentially, blocks also have a header. Transactions must be numbered and sequential. They will be executed by the Ethereum virtual machine to calculate the new state. Note that the order of transactions directly influences the new state. The number of transactions a block can hold is not fixed, as it depends on each transaction type. In general, a block contains a few hundred transactions, but it is theoretically possible to have no transactions at all. The block header contains essential information such as the block number, the exact time it was added to the blockchain, the hash of the previous block header, the account of the person who added the block, and the Merkle root of the transactions, among others. Don't worry if you don't know some of the words I mentioned, especially hash and Merkle root. The important thing is to understand that the header holds information about the block. Blocks are numbered and ordered, starting from block 0, or Genesis block. To calculate the current state, it is necessary to execute all transactions of each block, starting from the first transaction and the first block. The Genesis block is usually transaction-free and hard-coded. The header of each block stores information about the hash of the header of the previous block. This causes the blocks to be cryptographically linked. It is this structure that makes the ledger secure and tamper-resistant. As the blocks are cryptographically linked, any attempt to change a previous block will invalidate all subsequent blocks. Thus, the larger the blockchain size, from the block under consideration, the less likely it is that such a block can be changed. That is why it is said that the blockchain has a probabilistic block finality. Let's use our knowledge acquired in the last few classes to search for information about a specific block. We can do this by sending a JSON RPC request to a node, and asking it to execute the eth_getBlockByNumber method. Remember that we are using the recentninja.io website to send HTTP requests. The address of the node we will send the transaction to can be found on the chainlist.org website. The eth_getBlockByNumber method requires two parameters to be inserted into the parameter array. The first parameter is the block number, in hexadecimal, and the second is whether we want the return to include transaction details. In this example, we will fetch information about block number 1 million. In hexadecimal, 1 million is F4240. To indicate that the number is in hexadecimal, we add the 0x prefix. Let's click send and wait for the result of the request. The result will bring all the information about the block header. We can see the difficulty, the gas used, its hash, and the nonce, among others. Throughout this course, we will learn the meaning of almost all of these fields. Some are no longer used, as this block still used the consensus mechanism based on proof of work. Note that, as it is a relatively old block, this block has only 2 transactions. Currently, this is not common. You can retrieve information from any block, from the first block to the most recent one.